Okay guys, so today's emphasis is on the trig part here in the title. Yesterday was an emphasis on inverses in general. Today we're talking about literally inverse trig functions. Alright? So I would like to redo the same problem I did yesterday. I did it one way for you yesterday. I did number 25 for you a few minutes ago. But I'm going to show you that there's a much faster way to do all of this in the end. Okay, so we'll do it the long way and we'll do it the short way. Okay, so the graph is that of y equals arctan of x. This is the graph, right? And the point is the point 2 comma arctan of 2. This is the point. So I already know that the answer is going to be, for the equation of the tangent line, y equals some slope times x minus 2 plus arctan of 2. I already know that. In fact, I'm going to circle this because my answer is going to look just like that. I just need to put a number in there. Okay, so what is that number? Well, I'm supposed to take the derivative of arctan, and then I'm supposed to plug in 2. But there's a problem with that. I don't know how. I don't know how to take the derivative of arctan. I don't know what the derivative is. So instead, we will consider the inverse function. Consider instead y equals tan x. That's the inverse, right? But now you should be considering the point arctan 2 comma 2. Okay? So if you're going to consider the inverse function, you need to reverse your coordinates. Do you know how to find the derivative of this one?
Yes.
Yes. Okay, then let's do that. So y prime is going to be sec squared. And then I'm supposed to plug in the x value. That, unfortunately, is arctan 2. Yuck. That's okay. We've done this sort of thing in pre-calc days. Okay, so if you would like to use a calculator, you can. I'm going to actually draw a little triangle where the opposite is 2 and the adjacent is 1. So a little triangle here. I don't know what that angle is called. I'll just make a little mark there. The opposite is 2, the adjacent is 1. So this became sort of blueprints for a drawing. Okay, what would the hypotenuse be for this triangle? Root 5, correct. And what is my derivative? It's supposed to be secant squared of this triangle. So for this triangle, what is secant? That would be hypotenuse over adjacent. So that's root 5 over 1. So this simply comes out to 5. So how does this help me? Now I know what to put in my blank way up high. It's 1/5. Okay? If you distribute the 1/5, type in arctan of 2, you will find that this agrees with the given up above. There's got to be a better way to do this. Or are we forever stuck with the notion that when we don't know a derivative, we'll have to look at the inverse function? We don't want that either, right? So we need to know what the derivative of arctan is next time, so we don't have to do this little detour phase at the bottom. What if I just told you this? What if I told you that the derivative of y equals arctan of x is 1 over 1 plus x squared? What if I just told you that? And you just knew that somehow. That'd be awesome, because watch how easy this problem is. You would then just go like this. The graph is y equals arctan, right? The point is 2 comma arctan of 2, right? The tangent line would look like this. Basically, y equals blank times x minus 2 plus arctan of 2. But you know already now how to get the slope. It's right here. It's just 1 over 1 plus x squared. So that would just be 1 over 1 plus 2 squared. There it is, the 1/5. That's so much easier. Y equals 1/5 times x minus 2 plus arctan of 2. The problem is you didn't know that. You didn't know the derivative of arctan was 1 over 1 plus x squared. So today's, what my job is to show you and tell you the derivative of all 6 inverse trig functions so you can just use them instead of figuring them out. Okay? All right, so here we go. Why is the derivative of arctan 1 over 1 plus x squared? Why is that? So we already know the answer for this one. I gave it to you a minute ago. Let's see why, okay? It's important to know why. So, what I'm going to do is I'm going to invert this statement. So it says y equals arctan of x. I'm going to write that as tan y equals x. It's the same thing, more or less, okay? There's some questions you might have about domain. But listen, that's just the opposite statement, right? Okay, now, this means that I'm thinking of a triangle, and in that triangle, the angle is y. It's a right triangle. And if I write this x over 1, it means that the opposite is x and the adjacent's 1. So I'm going to try to draw a blue triangle, or a red triangle right here, like that, where the angle is y, the opposite is x, the adjacent is 1. What would my hypotenuse be? What's the Pythagorean theorem give us?
X squared plus 1 squared.
Yeah, square root, right? So basically you square the legs, add them, and then square root. Okay? Now, going back to the blue here, let's take the derivative of this expression, this equation, implicitly. So what's the derivative of tan y? Careful. Sec squared y prime, yeah, or dy dx, good. What's the derivative of x? That's the right side, x, 1. Okay, now look at your triangle and determine what secant is. Okay, secant is adjacent, it's hypotenuse over adjacent. So that would be basically square root of 1 plus x squared all over 1. Okay, so it's square root of 1 plus x squared all over 1. But this just gives us 1 plus x squared times y prime equals 1. And so we can conclude that y prime equals 1 over 1 plus x squared. This is the one and only time you have to ever derive this. From now on, you can just know that the derivative of arctan is 1 over 1 plus x squared. Okay? All right. What about arcsine? I can go back. So here's my work for that. So I'm going to do this with all 6. It goes really fast. Actually, I'm going to do the first 5. You'll do the last one. Okay? Next up is arcsine. Got it? Okay. Arcsine, I can write that as sine y equals x, or sine y equals x over 1. I can draw a red triangle where the angle is y. This time it's the opposite that's x, and the hypotenuse is 1. So the third side would actually be the square root of 1 squared minus x squared. So basically, this is my third side this time. Now I'll go back to here and I'll take the derivative implicitly. The derivative of sine y is cos y, y prime. The derivative of the right side is simply 1. According to my triangle, cosine is simply adjacent over hypotenuse, so it's square root of 1 minus x squared all over 1. And I divide and I get 1 over the square root of 1 minus x squared. This is the derivative of arcsine. You will be memorizing it. But if you should forget it, you can redo what I just did so that you don't have to memorize it. When I was in high school, my teacher did not go through the 6 derivatives and tell me what they were. My teacher taught me how to do the triangle thing. So I never had to memorize these. I just basically re-derived them each time I needed them, and I only needed on one out of every 50 problems, you know. But for me, it wasn't a memorization issue, you know. For you, it is. You guys are taking an AP test. I didn't take that test. In the AP test, you have limited time, so the more you have memorized, the faster you'll work, right? So try and commit these 6 to memory. All right. These are all going to start to look alike, so pay close attention. The next one I'm doing is arc cosine. There's no particular order to this. I'm just doing all of them here. Okay, so the first thing I'm going to do is rewrite this as cos y equals x. Or you can think of it as x over 1. My red triangle looks like this time. There's y. There's our angle. X is adjacent. 1 is hypotenuse. Hypotenuse squared minus leg squared is other leg squared. So we get this. This looks almost like our last diagram, except adjacent and opposite are flipped around. Let's take our derivative implicitly. So that's negative sine y, y prime, equals 1. Don't forget to take the derivative of that x over there. It's easy to forget. The triangle tells us that sine is opposite over hypotenuse, so that's a 1 minus x squared there. Let me rewrite that. There you go. And dividing, we get, actually it's almost the same exact answer as last time. It just has a negative 1 on top. Notice how similar the derivative of arc sine and arc cosine are. Almost exactly the same. Okay, next is, what did I pick next? Can't remember. Secant inverse. So you would just write sec y equals x. Draw a triangle. The angle is y. This time it's the hypotenuse over adjacent is x over 1. Be very careful with this one. This leg is square root of x squared minus 1. It's hypotenuse squared minus other leg squared square root. Okay, so just be very careful when you draw the triangle there. Take the derivative of this implicitly. Derivative of sec y. Okay, that's a little bit awkward. What's the derivative of sec y? Secant, right? So it's sec y tan y times y prime equals 1 this time. Okay, so we're going to have to look at the triangle twice. Sec y is hypotenuse over adjacent. That's simply x over 1. Tan y is opposite over adjacent. That's square root of x squared minus 1 over 1. And we end up dividing by both x and the square root of x squared minus 1. So y prime is a little awkward. It's 1 over x square root of x squared minus 1, like that. Okay, and I don't have time to explain this right now, but there are some domain concerns with the inverse secant graph. The inverse secant graph has kind of a strange domain. Okay, there are like some asymptotes and things, and it's a little confusing. So just know that this function, this derivative, technically is supposed to have an absolute value right here on the bottom. I put it in green. You're supposed to know that. But every question I've seen on the AP test that asks you to find the derivative of sec inverse, they stated in the instructions that x was positive, so that absolute value was not necessary. I've never seen that absolute value show up on the AP test. They always say x is positive and sort of avoid the issue. Technically it's there. I doubt you'll need to know that, but just in case, okay? Now we've done arc tan, we've done arc sine, we've done arc cosine, we've done arc secant. Does anyone care to guess what the next answer is going to be? Negative 1 on top. But the same thing? Okay, yeah, so for arc cosecant, turns out we're predicting our answer this time. Is the answer really negative 1 over absolute value of x times the square root of x squared minus 1? Probably, right? From our experience with sine and cosine, secant, cosecant, there's like this negative that pops up. Let's just draw the triangle and convince ourselves. So we write this as cosecant y equals x. Draw ourselves a triangle. Angle is y. Hypotenuse over opposite is x over 1. The third side would then be the square root of x squared minus 1. Taking the derivative implicitly, move this over here. Okay, taking the derivative implicitly gives us, what's the derivative of cosecant y? It's like the hardest one. It's negative, right? Cosica cotan. Cosica cotan. Sounds like a nice vacation spot. Okay, times y prime equals 1. So some awkward stuff there. All right, I need cosecant of y, that's hypotenuse over opposite. And I need cotangent of y, that's adjacent over opposite. Yes, our answer is correct at the top of the board. It is negative 1 over x square root of x squared minus 1. The absolute values show up again as a domain issue. You should know it, but you probably won't need it. Okay, that leaves us with one last one. And I thought maybe you could try drawing the triangle and deriving it yourself. It's the arc cotangent. You might even be able to guess the answer, because we already did arc tangent. But do it anyway, and see if it worked. Okay, so I'll run through it real quick, just to make the video complete. But this is cotan of y equals x over 1. The red triangle is like this, with an angle y here. Adjacent x, opposite 1. The hypotenuse is the square root of 1 plus x squared. Taking the derivative, we have negative cosecant squared y times y prime. Did you remember the negative? Okay, the derivative of the right side is 1. Okay, and now we're going to plug in cosecant from our triangle. So that would be hypotenuse over opposite. Hypotenuse over opposite. Okay, when we square, we just end up with basically negative 1 plus x squared times y prime equals 1, and dividing. Yes, this kind of is what we were expecting. If the derivative of arctan is 1 over 1 plus x squared, then the derivative of arccotan might just be the negative of that. Okay, so let's just put them all together in one table. The derivative of arc sine is 1 over the square root of 1 minus x squared. The derivative of arc cosine is just the opposite of that. The derivative of arc tan is 1 over 1 plus x squared. I think it's the easiest one to look at. And then arc cosecant was probably one of the more awkward ones. That's the one with a negative 1 on top. And then there's an absolute value x down here. And then this is x squared minus 1 in the radical. Yuck. Arc secant is positive. Version of the same. And arc cotangent is the opposite of arc tangent. So I always appreciate it when the AP test asks me for the derivative of arctan or arccotan, because those are the simplest. But occasionally they do go and ask you for the derivative of arc cosecant or something ugly. Okay, so I know that was a full lesson in a way, but we need to look at some examples because we can't forget the chain rule. Like, what do you do if it says arc sine of something else? Okay? So let's just run through some examples. It's just the chain rule, but this is basically an example where it looks like an arc cosine function, but then you look on the inside and it's not really x, right? Okay, so let's run through this chain rule style. Let's use purple. Okay, first thing I notice is this looks like arc cosine of something, which means it should have this basic structure. I just copied and pasted that structure from the previous page. Only the ratio here is not just x, it says 1 over x squared, so I guess I have to just put that in here. See? So now I need to multiply by the derivative of what was inside. So this right here, you know, is x to the minus 2. So I need the derivative of that, because that's part of my answer. So that's negative 2x to the minus 3, right? It's just the chain rule. We're just obeying the chain rule here. So if you clean this up a little bit, it's basically 2, and then on the bottom there's an x cubed and a square root of 1 minus 1 over x to the 4th. I might have you clean it up. I might let you just leave it like that. I'm not sure anything you do to this is going to make it look much better. So let's just leave it and move on. I wanted to show you that chain rule step. Okay, let's look at the next one. Arctan of 1 minus 3t. So first and foremost, this is an arctan. So the derivative should have the structure 1 over 1 plus something squared. Only it's not an x, it's a 1 minus 3t. Fair enough, we'll put that in here. Now we multiply by the derivative of what's inside. That would just be, what's the derivative of 1? 0, and the derivative of minus 3t is? Minus 3. Okay, so this one turns out to be negative 3 over 1 plus 1 minus 3t squared. Okay, let's try another one. Got to have some variety here. The next one is by far the hardest one, both notationally and mechanically. There's a lot of steps to it. There's a double chain rule, so everybody watch close. Okay, don't let the dr dx throw you off. The name of this function is r instead of y. Okay? So we're not going to let that bother us. We're still just finding the derivative. What does it mean to have this here? What does it mean? Bar x equals half.
The point you're going for, right?
Yeah, ultimately we're going to plug in half in the end. That's all it means. So please don't be intimidated by some of the new symbols. It means find the derivative and plug in half. All right. Also, you'll notice that it says 1 over arc secant. See? Wait a minute, is that just then arc cosine or something? Don't play that game. Never play that game. Okay? Never try to mix the concept of reciprocals and inverses. Okay? Don't play that game. This doesn't mean secant 4x on top. Okay? Just follow along. Let's just write this as, how about just write it as r equals, and then we'll put sec inverse 4x to the minus 1. That's what it means, right? 1 over something. This first and foremost is not a secant inverse. It's something to the minus 1. See the structure? It's really just blah blah to the minus 1. So we start these problems off by bringing down the minus 1. Okay? Just look at the power rule first, actually. All right, so we're going to bring this out front and then also take away a power. So it's going to look like this. Dr dx is negative 1 out front. The secant inverse 4x nonsense now has a negative 2 power. Now let's look on the inside. What are we looking at? We are looking at an arc secant problem. Arc secant has an ugly structure. The derivative structure for that thing is 1 over absolute value of something, square root of that something squared minus 1. Awful. But that's what it is. And it's not x, it's 4x. So let's put that in. And that's not all. We need the derivative of that 4x also. So we need to multiply now by 4. Okay, now this is our answer, and we can try and tidy it up. Okay, but wasn't the problem asking us to plug in a half? I say we do it as soon as possible, before we mess this all up, before we start thinking of negative ones as powers and stuff. Okay, so why don't we just plug in the 2, or the half right now. Okay, so dr dx at a half is negative 1 times sec inverse of 2 to the minus 2 times 1 over absolute value of 2 times the square root of 2 squared minus 1 times 4. I did nothing on that step except plug in half, so all of my 4x's became 2's basically. Taking it slow, I don't want to mess this up. Some of this stuff is pretty easy, like this whole batch right here just becomes 2 over rad 3. So that part's not too hard. What is this arc secant 2 business? Can you think of an angle where the secant is 2? Yeah, it's the same question as what angle has a cosine of a half. It's the same question. So this would be pi over 3. It needs to be flipped and squared, which makes it a 9 over pi squared. So there's a negative 1 there, there's a 9 over pi squared, there's a 2 and a rad 3, and this gives me negative 18 over pi squared rad 3, and I will rationalize. Multiplying top and bottom by rad 3, I get negative 6 rad 3 over pi squared.
What about the 4?
There's no, the 4 was absorbed into this. I said this whole batch becomes 2 over rad 3.
Can you do that?
Sure. Well, it's 4 over the absolute value of 2, which is just 2.
Yeah.
And then 2 squared minus 1 is 3.
Yeah.
So it's kind of a debate, like how many steps do I want to show, you know? Eventually I have to start collapsing it down. I wanted to focus on this front part here. I got the last part collapsed quickly, but this part here is strict. You got to really watch out for your negatives. You got powers going on. I love this problem for many reasons. Okay, it really brings out everything I want you to know. I want you to see it as something to the minus 1. I want you to see the double chain rule. Study this. It's a great test question for me. Even a minus sign error is a thinking error here, isn't it? So, okay, yes?
How did you determine that the secant derivative one was pi over 3?
Oh, you're talking about that step. That's a unit circle question. This means what angle has a secant of 2? Which is the same question as what angle has a cosine of a half? Is that better? You like that better? Arc cosine half? Same question. There are 2 angles in the unit circle that have cos inverse of half, but we're only supposed to be looking in the top half of the unit circle when we do an arc cosine. So it's the point 60 degrees, you know, pi over 3. Pi over 3. Yes?
When you took pi over 3 and made it to the negative 2 power, why did you flip it?
Because the negative on this negative 2 means flip me, and the 2 means square me. This means flip me and square me.
Yeah.
So he's saying flip me, square me. So he becomes 9 over pi squared.
So is 1 over pi
It means
over
1 over pi over 3, which is 3 over pi, and then square that. Yeah. Lots to think about there, but I like this problem. I think it makes a great test question. You know, you can get partial credit for parts of it, but you can nail this if you're careful, right? Notice I plugged in the half as soon as possible. That's my motto on AP test questions too. So there's your homework. I think it'll go pretty fast because now you have the derivatives. So anytime you need the slope of a tangent line, just stick it into the formula. Stick the x in and you're good to go. So it's 11 problems there.